It's your boy D. Burton here. Remember to smash that like button and subscribe.
All right. In this video, we're going to learn about the cosecant function. And I see we have a change in period with the b value. And wait, this -2, is this a phase shift or is this a vertical shift? It is a vertical shift. There's no parentheses. As opposed to number 32, if we get that far, there's a phase. This is what a phase shift will look like, and a vertical shift. Now, keep in mind that the cosecant is the reciprocal of the sine function. So our strategy will be to make a quick sketch of the sine function and then use that as a guide in order to do the cosecant function. So here I go. The b value is 1/3. Understand that. All right? 1/3 is the b value. So I need to find the period before I do very much else. The period is always the regular period, which in this case is 2 pi, divided by the b value, which is 1/3. All right? So 2 pi divided by 1/3. Multiplying by the reciprocal, that's going to give me 6 pi. Does that make sense so far? Okay. So the period is 6 pi. That's going to help me set up my graph. Okay, let's see. It's going to be down 2, so I'm going to leave myself space. So here we go. Here's my x-axis. All right, remember, I'm sketching the sine function. That's my goal. There is no phase shift, so the function's going to start right at 0. So I can go ahead and just draw my y-axis without worrying about it. And the period is 6 pi. Since there's no phase shift, I can just go out to the period and mark it, and then split it up into 4 pieces. So halfway out, that will be 3 pi. Half of that will be 3 pi over 2. Halfway in between these, you can either think of it as triple the first one, which makes this 9 pi over 2. Or you can think of it as the average of 3 and 6. You add them up and divide by 2. 3 plus 6 is 9. Divide by 2, you get 9 over 2. All right, so that's those 3 markings. Now, let's go ahead and think about the vertical shift. I'm going to need that. Because of that -2, I'm going to have a vertical shift of down 2. So I'm going to go 1, 2. -1, -2. The a value is 1. So I'm going to have an amplitude of 1 for my sine function. So I'm going to go down 1 more mark for that. So -3. Okay, so my midline is going to be here at the -2 though. So I'm going to go ahead and put a dotted line for my midline. So this will be my midline. And what I like to do is I also put lines for my amplitude, my a value. I'm doing it in yellow because this is optional and I don't want it to stand out too much. But so this yellow line represents my a value, this one too. All right, it just helps me do my graph more accurately. So, you can decide whether or not you want to be on my level. Okay. So now we're going to do a sketch of the sine function, all right, because this is the reciprocal of the sine function. Let us not forget the phase shift. We can go ahead and just say none. So here comes the sine function. We know that the sine function starts out on the midline. So the sine function is going to start right there at -2. And then it's going to go up the a value, to its highest point, and then back to the midline, and then down the a value, and then back to the midline. So here's my sketch, a very light sketch of the sine function. Okay, now there will be asymptotes, vertical asymptotes, where the sine function touches the midline, which used to be the x-axis before we shifted it. Okay, that's why we have asymptotes there, is because before we shifted things, if you had a 0 in the denominator, that's undefined. So the places where the sine function touches the midline, that's where the sine function was 0 before we shifted things. So there should be a vertical asymptote in these 3 places. All right, so I'm going to put a vertical asymptote right here, okay, on the y-axis. I'm going to put another vertical asymptote right here at 3 pi. And another vertical asymptote will be here at 6 pi. So the actual cosecant function that we're trying to graph, we know that the cosecant function will be the same as the sine function at the extremes, at the highs and lows. So these 2 blue dots will be on the cosecant function. After that, I just have to approach the asymptotes. So I'm going to approach the asymptotes on the left, and I'm going to approach the asymptotes on the right. All right, same thing with this one. Approach the asymptotes on the left, approach the asymptotes on the right. So the blue represents the graph of your cosecant function here. Any questions so far? Okay. X-intercepts. There are x-intercepts I can see up here, but again, when you have x-intercepts on these trig functions and they're between the lines, you really need a graphing calculator or something to find those x-intercepts. So we're just going to skirt for right now. So don't worry about that. Vertical asymptote equations, we can do that. My first vertical asymptote is right at 0, right? It's right on the y-axis. So I might say x equals 0 for that one. But then I'm going to have to add an expression to represent all of the other vertical asymptotes. I notice that I run into a vertical asymptote after half of a period. So every half period, I get a vertical asymptote. Half of a period, see the period is 6 pi, half of a period is 3 pi. So I'm going to add 3 pi, and then I'm going to say 3 pi n, where the n is representing the repetition. All right, it's a multiplier to represent all of the other asymptotes. If I let n be an integer, then it captures not only the positive asymptotes going to the right, but also the negative ones that are going to the left. I don't really need the 0 though, so if I want to be more sophisticated about it, I will just say x equals 3 pi n without the 0. I wouldn't mark it wrong if you put the 0 there, but you know, it's mathematically immature to put a 0 there. All right, that's it for number 31. Any questions about it? All right, I got a good question about what about domain and range? We should be able to do the domain and range, and sometimes you will be asked for the domain and range, perhaps on the quiz. So I'm going to do both of those real quick. So the domain, all right, the domain we basically wind up saying everything except for the vertical asymptotes. So for the domain, we're going to say all real numbers except x cannot equal the vertical asymptotes, which is 3 pi n. So x cannot equal 3 pi n. So that's the domain. Now the range. We just have to do the range in 2 parts. So looking at the lower portion of the graph, right, just the blue, the lower portion here goes from -infinity up to -3. So I'm going to say, okay, the first part of my range is from -infinity to -3. Am I going to put a parenthesis or a bracket on the? I'm going to put a bracket because it touches -3. That's not an asymptote or anything. So bracket. And then I say union, like this. All right, that's what you have to do when you have more than one part. Now the upper portion of the graph, what do you think I'm going to say now? Bracket and what? -1 to infinity. Okay, that's how you would write the range.